Okay, today we're going to talk about the introduction to functions, and we're going to basically spending our time on input and output and the algebra that goes along with it. So we're going to evaluate a function, we're going to find inputs, and we're going to solve equations, and then we're going to look at outputs and inputs from tables and graphs. Alright, evaluating a function means figuring out the value of the function's output from a particular value of the input. So here's a formula, and this is a true formula. This is Celsius equals 5/9 parentheses Fahrenheit minus 32. And this is an actual conversion unit, so here I can put any Fahrenheit temperature I want in my function, do this following work with it, and then out will come what the Celsius temperature would be. And I use this a lot when, especially if I'm listening on the radio and they tell you the Fahrenheit and you want to know what it is for Celsius for Canada, we'll say this is a good way to do it. So the F is, I can put any Fahrenheit I want in there, so that's my input, is the Fahrenheit. After I do all this work to it, out comes the output, or the Celsius. If I were going to write this as a point, it'd be the point F, comma, C. So this is my input and this is my output. It's like in the X and the Y spot. Independent variable is always your input, because I can pick anything I want to put in there, and the dependent is my output, or my C. Okay, now here's the conversion formula that I can put any Celsius I want in here and do some work to it, and I would get the Fahrenheit temperature. So the input is switched in this case. It's going to be the C, and the output's going to be the F, and if I were going to make a point, it'd be CF in this X and Y position. And the independent is going to be whatever I want to put in, which is the input, and this again is dependent upon my independent variable, is the output. Okay? Alright, next we're going to look at function notation a little bit. And since a function can take on many forms, it is convenient to have names for different types of functions. If we name a function f, for example, there is a convenient notation. Note, you don't need a formula to use the notation. Okay, you don't need one. Example, let f of t be the total number of cases of flu reported in Carthage. So right here, this is the number of cases of flu. Alright? And it's on the 10th day of the year. So this is the day of the year. And f of t, which is actually q, is going to be the number of cases of flu. So if I were going to do a point here, my point would be, let's put it up here, t, because that's my input. My output is q. So this is the day of the year, and this is the number of cases of flu. Okay? You could also write this as t, f of t. They just said you could call f of t q, so that's why I'm just trying to get you used to the notation. So, if I were to ask you, what does this mean, f of 103, well, that would be on the 103rd day of the year, it's going to be the number of flu cases. Actually, that would sound better if you said it's the number of flu cases on the 103rd day of the year. Either way it works. So this one would be the number of flu cases on the 147th day of the year. In Carthage, of course. How would I interpret this? Now this, they actually gave us a number. Here we didn't have a clue. We just knew it was the number of flu cases. We just didn't know how many. Here they're saying on the 103rd day of the year, there are actually 56. So the point is really 103.56 if I were going to graph it. And the number of flu cases depends on what day of the year you're talking about. So here it would be on the 103rd day of the year, there were 56 flu cases in Carthage. So again, you took a math sentence and you made it an English sentence. So I made this little slide here for you. So it kind of has all the basics. Functions can be described by formulas, but functions are not formulas. So they're not one and the same. F of anything can have intrinsic meaning. They are not just simply cues to evaluate formulas. And remember, whatever's in the parentheses is your input or your x value, if you will. We often do have formulas to describe functions, and we find the output value by substituting an input value. So the input is always inside the parentheses. Alright, let's practice some algebra. So we talked about what functions mean. Now these are some algebra. So now I actually do have a formula. I have f of y equals y squared minus 3y. So now when I do f of 2, and I want you to see exactly what I do, if I put a 2 here, that means I put it here and here. Now when I do that, please notice I put it in parentheses, so that when I do that, I now have 4 minus 6, or negative 2. So the point 2, negative 2 would be on that graph. If I did f of negative 4, it's the same thing. And negative 4 is here, so it's got to go here and here. So I have negative 4 squared minus 3 times negative 4. And when I put that in my calculator, I get 28. If I did f of b, if I just put a b in there, it'd be b squared minus 3b. So that's pretty obvious. Now we got 2b in here. So if I put a 2b in here, now this is where it's really important that you show your parentheses, because if you don't, the algebra could be wrong. And here especially, everybody gets that it's b squared, but don't forget you have to square the 2 also. So that's really 4b squared minus 6b. If I put a 3y in there, I would have 3y squared minus 3 times 3y, and don't forget what I just showed you above. This is actually 9y squared minus 9y, and there's nothing more I can do to it. You can factor it, but you don't need to. They just said evaluate, and so that's what we're doing. Now this one here says f of x plus h. So wherever this x plus h is going to be here, it's going to be here and here. So let's practice that. So I have x plus h squared minus 3 times x plus h. And if you remember, when this is x plus h squared, you can do that over here if you want, but x plus h times x plus h is going to be x squared plus 2xh plus h squared minus, and then we're going to go through and do that, 3x minus 3h. So if you need to do this over here and actually do this and then combine the middle and put it over here, that's fine. Then when I'm done here, I look and say, can I combine anything? And I can't, because I have an x squared, an xh term. I don't have anything that matches, so that's it. So that's pretty simple for that. Now let's try this again with a rational function or fraction. And I want to do r of 2. So if there's a 2 here, it's going to be here and here. So I have 2 cubed. Make sure you put in parentheses, please. Minus 1 all over 7 plus 2. And that is 2 cubed is 8 minus 1. So that's going to be 7 over 9. See, and it says simplify as appropriate, so there's nothing to simplify in that. R of h is going to be, again, plugging it in the same thing, h cubed minus 1 over 7 plus h. And there's really nothing you can do with that one, so that's the answer to this one. Now let's look at this one here. I'm going to put an h minus 2 in there. Now you can't see it, but I'm going to put it wherever the x is. So it's going to be h minus 2 cubed minus 1 all over 7 plus h minus 2. Now this one is a little bit more complicated, so way over here, or you can do it over here, doesn't matter. We're going to multiply out h minus 2 cubed so we can do this. which is h minus 2 times h minus 2 times h minus 2. So I'm going to multiply these two first, and then I'm going to multiply with that. So I've got h squared, and then I've got minus 2h plus minus 2h, so it's minus 4h plus 4. So I've multiplied these two together. Now I'm going to multiply this all by h minus 2. And when you do this, you're going to use this term first and do the distributive property 3 times, and then this 3 times, and then combine. So I have h cubed minus 4h squared plus 4h minus 2h squared plus 8h minus 8. And notice I kind of put them where they can be combined. And when I did that, I've got h cubed minus 6h squared plus 12h minus 8. So what I'm going to do here is, in this spot, I'm going to put this whole thing. And the only thing is I got to subtract 1, so this is going to turn to a negative 9. So I have h cubed minus 6h squared plus 12h. And I have a minus 8, but I know I got to take 1 from it, so it's going to turn to minus 9 all over. Then I have a 7 plus h minus 2. Well, the 7 minus 2 is going to be 5 plus h, or you can say h plus 5, it doesn't matter. And that's my answer. Now, this one says they want you to see here I've got r of h. Then here I have r of h minus 2, where it's all in the input area. Now I have r of h minus 2. Do you see the difference? Well, r of h we've already done up here, so you don't have to do it again. So this one's going to require some algebra, because here's this. And then I'm going to subtract a 2. Now when I subtract the 2, I'm going to put it over a 1. I have to find a common denominator. I can't leave it that way. This is why we did all that algebra earlier this year. So the denominator is going to be 7 plus h, which means that h cubed minus 1 is okay. Now if this is the denominator, I have to multiply it by the top here. That's my smart 1. So I have minus 2 times 7, or minus 14, minus 2h. Okay, so then I look at it and say, is there anything else that can be combined? And you betcha these two can go together. So this really comes out to be h cubed minus 2h minus 15 all over 7 plus h. So do you see the difference? This is my final answer. This is right here just r of h, and here it was r of h minus 2. So it's almost like you get something different every time, because it's how we're doing this. Now if I did r of h minus r of 2, we've done r of h up here, and I think r of 2 was even up the top here, which I think was 7/9 if I remember. So what we're going to do is say r of h, which we have here is h cubed, we've already done this, minus 1 all over 7 plus h, and we're going to subtract 7/9. And this is not wrong, but I want it in one single common denominator. So we're going to have a common denominator of 9 times 7 plus h. So here my smart 1 is going to be 9 over 9. So I have a 9h cubed minus 9. Here my smart 1 is 7 plus h over 7 plus h. It's a plus. So I have minus, minus 49 minus 7h, and then I look and see what I can put together, and I see that I can put these two together. So I have 9h cubed, and I'm going in descending order, minus 7h, and then these two can go together as minus 58 all over 9 times 7 plus h. Now I don't care if you multiply the denominator through or leave it in factored form, but this is fine. Okay? Alright, let's practice some more here. Now we've got g of 3. So if you want to shut this off, I'm going to go through and kind of do this, and then come back and see if you match. Go ahead. I'm not going to really stop this, but you can stop the tape. But now we have g of x is this, and we're going to go through and do all of these for more practice. So go ahead and shut it off and do it, and then check. So So g of 3, when I do this one, it all comes out to be this. So that's 5/4. G of a is going to be a squared plus 1. And there's really nothing to do with that. G of negative 1, be careful with the parentheses. And that's going to come out to be a 2 over a 4, or 1/2. And g of a minus 2, I put that in that spot. A minus 2 squared plus 1, 5 plus a minus 2. When I do that one and get done with all the algebra, doing a minus 2 times a minus 2 over here, which is a squared minus 4a plus 4, I put it in that spot. This is the final answer you should get, is a squared minus 4a plus 5 all over a plus 3. And there's a couple more here at the bottom. G of a minus g of 2, we already did g of a, so that's going to be a squared minus, plus 1 all over 5 plus a. And then g of 2, which did we do g of 2 yet? Maybe not. So g of 2, when I put g of 2 in there, come on, let's work here. Minus, and g of 2 comes out to be 2 squared plus 1 over 5 plus 2. And when I get all done with a common denominator, I should have 7a squared minus 5a minus 18 all over 7a plus 35. And then g of a minus 2 is going to be a squared plus 1 all over 5 plus a minus 2, and make sure you I put that over a 1. Find a common denominator. You should get a squared minus 2a minus 9 all over 5 plus a. So make sure you check your algebra so you get those answers. Alright, now for example number 4, I have y equals 1 over radical x minus 4, which may look weird to you because I have a radical in the denominator, but this is not why we're doing this, basically. If I were going to graph this, which I like graphing and looking at this, it looks like this. And remember, a sketch, whoops, should be a good sketch. So you label your x and y axis. And here's x equals 4, because there's an asymptote here. And you're going to see the graph is going to kind of look like this, which is interesting. And I can kind of tell that it's going to look like that because I can't have a 4 in the denominator. If I did, I'd have a 0. So it's not going to ever equal a 4 in the denominator. So that's why my function only exists this way. So it says find the x value that results in a y of 2. So basically, I'm going to put a 2 right here in this y spot and then solve for x. So I've got 2 equals 1 over radical x minus 4. And I'm going to, when I cross multiply, I always put that over 1. So I have 2 times radical x minus 4 is going to equal 1. And then I'm going to square both sides. You could divide by 2, but I don't want to have a fraction. So remember to square the 2. So I have 4 times x minus 4 equals 1. And then so I have x minus 4 equals 1/4. So x is going to equal 4 1/4, or 4.25. So basically what you just found was that 4.25 is when my y value is 2. So the point 4.252 should be on the graph. And you can graph it and look at your table and it would be there. Then here they said, okay, is there an x value that results in a y of -2? Well, if we look at our picture, y equaling -2 is down here. It doesn't look like our function ever gets there, so I think the answer is going to be no. So let's say no, and let's see if we can prove it with algebra. So I'm going to say -2, does that ever equal 1 over radical x minus 4? So we're going to do the same thing, put it over 1, cross multiply. Okay, and then I want to show you something. We could square both sides and keep going, but if I divide by -1/2, I have radical x minus 4 equals -1/2. And I know that will never happen because a radical can never equal anything negative. So you got to be careful with that and look at your graph. So there's not going to be an x value that results in a y of -2 because the function doesn't exist. Alright, now let's look at some tables here. The table below shows the revenue received and to be received from the NFL and the network TV as a function of the year T since 1975. So when time is 0, this is since 1975. So 0 really stands for the year 1975. This is 1980, 1985. Okay, so time is 0 right here. So what they want to know is evaluate and interpret f of 25. Well, f of 25 is, here's my 25. I look down here and it's 2200. Okay, that's great. I evaluated it. Now, if I say interpret, I want you to tell me what that means in words. And since it's 25, and this is 75, if I said 25 plus 75, I'm going to get 2000. So this is really the year 2000. So I can say in 2000, because that's what that year is, the revenue received oops, I spelled received wrong. Revenue received from the NFL was, and remember this is in millions, $2,200 million. Okay, so that's what that means. Now it says solve and interpret f of t equals 1159. Okay, so if you look at this, I have 1159 right here. So I see that f of what? 20 equals 1159. And what does that mean? Well, if this is 20, this is in 1995. The revenue received from the NFL was, and look down here, $11.59 million. Okay, so that's how you read a table. Now I'm going to show you this example because this is kind of good for you guys to see this. But a man drives from his home to the store and back. The entire trip takes 30 minutes. The graph gives his velocity, or his speed, if you will, but okay, in miles per hour as a function of time since he left home. A negative velocity means he's traveling away from the store and back home. So you can't drive backwards, but this means he just turned around and he's going back home. Okay, so this is for 30 minutes. So this part here is to the store. And down here is coming back from the store. Okay, so this is the same example. We're going to evaluate and interpret. So we're going to first do V of 5. So if I look at V of 5, which is about right here, so I came up here, it looks like it's about, because this is 5, oops, sorry, it's not 5, 5's over here. So if I do V of 5, that's right here, it looks like it's 0 miles per hour. So what does that mean? Well, 5 minutes from when he left home, he's basically stopped. Now he could be at a light or he pulled over, you don't know, but he's basically stopped. Okay? V of 24, okay, if I come over here, V of 24 is right here. If I could look down here, it looks like he's driving 40 miles per hour, but it's negative. So you can't drive backwards, so that just means he's going 40 miles per hour back home. So this is going to be negative 40 miles per hour is what you get from the graph, and what you would say is after 24 minutes he is traveling 40 miles per hour back home. Okay? Now V of 8 minus V of 6 is, you're just going to go to your graph and look at V of 8. So let's kind of move this up a little bit. So it looks like V of 8 is about 35 miles per hour. So this is 35 miles per hour. And then V of 6 looks like this is at 0 miles per hour. So it looks like it's 35 miles per hour. Now if I were going to interpret that, this shows that the speed increased by 30 miles per hour in that interval between 6 and 8 minutes. So you can say between 6 and 8 minutes, his speed increased 35 miles per hour. And V of negative 3, well, there isn't any graph over here for V of negative 3, so it doesn't exist. You could say that he's at home at V of negative 3. But on our graph, it doesn't exist. He's at home. Maybe he's putting his shoes on. I don't know. Okay? Last slide I want to show you about this was the same graph. I want to go through here again and evaluate, interpret V of t equals 15. So now I want to know, when is the velocity 15? So the velocity is 15. If we drew a line here, its velocity is 15 here, 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 here. And this is 15 miles per hour. So at those 4 times, which roughly is going to be about 75 minutes and 3.75 minutes, it looks like, and 6.5 and 15.5 minutes. He is traveling 15 miles per hour. Okay? And this I want to change to a negative 20. So here I want to know at what times he was traveling back home. And it looks like about 19.5 minutes and 29 minutes. And if I was interpreting that, it looks like he's driving 20 miles per hour back home at 19.5 minutes and 29 minutes. And then here it says find the times when it's the same as V of 7. Well, if I do V of 7, let's look at this here. V of 7 looks like it's about maybe 29 miles per hour or 27 miles per hour. So basically you want to know what times, because this whole thing is about 27 miles per hour. At what time is it 27 miles per hour? So basically I'm looking for this. What time am I doing 27 miles per hour? And if I look at the graph, it's roughly 7 and 15 minutes. Okay, that is it for the functions introduction.